Hello, this is the luckiest maths teacher in the world. We now turn our attention to similar triangles. Last lesson we looked at congruent triangles. And remember that two triangles were congruent if they had three pairs of equal sides and three pairs of equal angles. Essentially, they were the same triangle, but the orientation could be different. So we might have a triangle like this, and we could rotate it, reflect it, or whatever. And if we have 1, 2, 3 pairs of equal sides. There's also 3 pairs of equal angles, so corresponding angles have to equal. So those two would be equal, and these two would be equal, and the like. So these are essentially the same triangle. So let's look at similar triangles. Now you know that similar means alike, but in maths we have very specific definitions for things. We're not just talking about whether two triangles are alike. There are two conditions that need to be met, both of them need to be met, for two triangles to be similar. So these are the two conditions on the screen. Feel free to pause and copy down if you like. So two triangles are similar if all their sides are in proportion, and also there are two pairs of equal sides amongst those two triangles. And two triangles are similar only if both of these are true. Okay? So let's look at what we're talking about. So let's say I have this triangle here, and I have one that's the same shape but just a bit smaller. Okay? So let's say that this angle are equal. We've got another pair of equal angles here, and this one, right? Now clearly these two triangles are not congruent. They can't possibly be congruent because they're not the same size. In other words, there's no pairs of equal sides there. So they're not going to satisfy any of the tests that we went through for congruence from last lesson. But they're sort of the same shape, and that's what similar triangles are. They're the same shape, except one of them is just enlarged. And we say it's been enlarged by a scale factor. So if I take a triangle and I double each of its sides, then I have a similar triangle. So in similar triangles, because they're the same shape, there are 3 pairs of equal angles. And because the smaller one's kind of been enlarged, that's what we mean by saying all the sides are in proportion. So both of these conditions must be met. Now I just want to quickly look at the second condition. It says that for triangles to be similar, they must have 2 pairs of equal angles. Well, actually, they must have 3 pairs of equal angles, but if they have 2 pairs of equal angles, they will also have 3 pairs of equal angles. So what I'm saying by that is, so let's say I tell you that these two angles here are equal to 60 degrees. And then I tell you that these two angles here are both equal to, say, 50 degrees. So what I have there is 2 pairs of equal angles, but because the angle sum of any triangle is 180, there's only one option for the size of these angles. They must both be 70 degrees. So 2 pairs of equal angles implies 3 pairs of equal angles. All right, let's look at a few examples. So on your screen now, there are a pair of similar triangles. So I'm just telling you they're similar. We don't need to know how to prove them just yet. We'll do that in a second. So what you can see is that if I put these sides in a ratio, it'll be equal for both triangles. So this small triangle here, the ratio is 3 to 4 to 5, smallest to middle to largest. In the other triangle, the ratio is 9 to 12 to 15. But because you're all very good with ratios, we can simplify these. Much like simplifying fractions, we divide by the highest number that goes into all 3 numbers, which is, of course, 3. So if I divide this by 3, 9 divided 3 is 3, 12 divided 3 is 4, 15 divided 3 is 5. I have the sides in the same ratio or same proportion as each other. So what we say is that we've basically taken this small triangle and we've enlarged it by a certain factor. So the factor is what we've times each side by in the small triangle to get the large triangle. So the scale factor here, just like we did for congruent triangles, we have to match up corresponding sides. So this side here corresponds to this side here corresponds to this side here, and so on. So the scale factor is 9 over 3, which is the same as 12 over 4 or 15 over 5. All of that equals 3. So what I'm saying is these two triangles are similar, and what makes them similar is that I've taken this triangle here and I've multiplied each of its sides by 3. So not only are the sides of this triangle in the same proportion as the sides of this triangle, this side and this side are in the same proportion as this side, and also this side and this side. The scale factor is consistent. That's what I mean by similar triangles. So we can use this to find unknown sides in triangles that we know are similar. So let's say I've got these two triangles here, and I'm telling you that they're similar again. We're going to learn how to prove that they're similar in a second. But let's say I've given you these two triangles and I tell you they're similar. Okay, so that means that each side is in proportion. So we have to match up corresponding sides. So this side and this side must be in the same proportion as this side and this side because the two sides are corresponding and because the two triangles are similar. Okay, so the scale factor is what we need to know this. So the scale factor is what did I times by the side in the smaller triangle to get the one in the larger. So this would just be 9 divided by 6, which is 1.5. We always do the larger triangle divide the smaller triangle. So the scale factor is 1.5. So I'm taking each side of this triangle, 1, and multiplying it by 1.5 to get triangle 2. So, of course, x would just be 8 times 1.5, which is 12. Okay? Now let's say that I tell you that this side here is, say, 18, and you have to find this side here. Why? Well, we already know the scale factor's 1.5, but here we don't multiply, we need to divide, because we're going from the larger triangle to the smaller triangle. So I know that I took y, so to get from this side to this side, I know I took y, multiplied by 1.5, and got 18. So to find what one of the sides is in the smaller triangle, I need to divide. So this would be y equals 18 divided by 1.5, which gives me 12. Okay? So, just like that, similar triangles can be used to find unknown sides, and you need to know the scale factor. Now we're going to look at actually proving that two triangles are similar. So I told you before that for two triangles to be similar, all the sides need to be in proportion, and there need to be 2, which implies 3 pairs of equal angles. But just like for congruent triangles, we don't need to show all of that. There are a few tests. So these are the tests for similarity. So to show that two triangles are similar, we can use the AAA test, which means we show that all angles are equal. In other words, there are 3 pairs of equal angles amongst the two triangles. So if that is true, if there are 3 pairs of equal angles, then the sides will also be in the same proportion. So we can use PPP, or it's sometimes also called SSS. It's just a bit confusing because the S for similarity doesn't mean the same as the S in congruence. Here, each of the P's or S's means side in proportion. So if we show that for two triangles, their sides are in the same proportion, then we have shown that they're similar. The 3 angles, there will also be 3 pairs of equal angles. So similar to the, sorry for the pun, similar to the SAS test for congruence, there's PAP or SAS in similarity, but A, the angle, has to be the one between the two sides. So in congruence testing, SAS, the A had to be the angle between the 2 pairs of equal sides. Now it has to be between the 2 pairs of sides that are in proportion. And analogous to the RHS test for congruence, there's RHP, or it's also called RHS here too. Of course, this time the S means side in proportion. So that means R for right angle, H means for hypotenuse, and P just means one of the other 2 sides in proportion. Okay, so these are the tests. And similar to proving congruence, we need to state reasons why sides are in proportion or angles are equal. We need to do this formally. So I will show you an example now. So let's look at these two triangles that we have here. So ABC and DEF. So I want to prove that they are similar. So I have to give a convincing argument that they're similar. So what I can say is that AB, which is 40, to AC to BC equals 40 to 50 to 60, just like I did in a previous example. I can divide these by the highest number that goes into them, is the ratio 4 to 5 to 6, which is exactly the same ratio as in the other triangle DE to DF to EF, okay? Now this is sufficient. I've shown that all sides are in proportion, so I can just write, therefore, triangle ABC is similar to, you can use this one or this symbol with the 3 lines, whatever, I don't mind, is similar to triangle DEF, and just like for congruence, we have to write a statement saying why, and this is SSS or PPP. So these two triangles are in fact similar because all the sides are in proportion, and therefore corresponding angles will also be equal. And we can do that without measuring them, okay? So I'm going to give one more example. Okay, so for this last example, I've got to prove that this big triangle ABD is similar to this small triangle in here. So because this is a question asking me to prove, I have to write a formal statement, formal set of reasons. So first off, I know that this angle here is in both triangles, so obviously it's equal in both triangles. So I can write it like this, angle EDC is common, so that's sort of one pair of equal angles. Now, because I've told you that AB and EC are parallel, you can take your pick. I'm going to choose this angle here and this angle here. They will be equal. The reason is they're corresponding. This is why we did the geometry review a couple of lessons ago. So I'll write that formally. I'm going to write angle ABC is equal to angle DCE, and the reason is that the two angles are corresponding angles of parallel lines. You can just write corresponding. So I've shown that there are two pairs of equal angles, and that means therefore that the other angle will be equal. So angle DAB is, this angle here is going to be equal to this angle here. They're also corresponding angles, but it wouldn't matter even if we didn't know that. They must be equal to each other because we have 1, 2 pairs of equal angles. The third must also be. So I'm just going to write angle sum of triangle, and that's the third A. So therefore I've shown that triangle ABD is similar to triangle ECD, and the reason is AAA. So let's just have a quick look. Obviously the two triangles are not congruent because one is larger than the other. So one more thing just before I end the video is I want you to understand that if two triangles are congruent, then they are similar. The scale factor is just 1. But if two triangles are similar, as they are in this case, that does not mean that they are congruent. So having all 3 angles equal, as in this case, shows us why that's not a test for congruence. Two triangles, even if they have 3 pairs of equal angles, are not necessarily congruent. Hope you've enjoyed the video. This has been the luckiest maths teacher in the world. Have a great day.